Ram Ram Coders. Today again I created a webinar instead of a live class, so I think you won't be able to unmute yourself, right? So today let's do a thing, correct? We will discuss the questions in brief, quickly, right? Then we will I open the common mic, right? So that you all can speak for discussions, okay? Till then, I will try my best to explain you in the best possible manner it's possible. And if you encounter any doubt, right, you can just note it down somewhere or you can paste in the chat, right? I'll try to answer those, right? But no issues. At the end, we'll discuss every single doubt properly. Okay. So, yeah, moving on to the first question. I think this was a good contest. Minimum number game. You are given a zero index array nums of even length, and there is also an empty array. Ayush and Bob decided to play a game where in every round Ayush and Bob will do one move. Okay. Every round, first Ayush will remove the minimum element from the nums and then Bob does the same. Now first Bob will append the removed element in the array, then Ayush does the same. Okay. The game continues until nums becomes empty. Return the resulting array error. Okay. So if you look at an example, right? 5, 4, 2, 3. So first Ayush gives the move, right? And Ayush will remove 2. Alice moves 2 and then Bob will remove 3, correct? Then in first Bob appends 3 and then Alice appends 2. Okay. At the beginning of round 2, the array number is okay. So yeah, we have here two different arrays. Now I got the question. Actually, I was confused. See 5, 4, 2, 3, correct? Then one more array which is empty. Now first Alice moves and Alice takes out this one, right? And then Bob moves and Bob takes out this one, correct? These two are moved and now in one more array, Bob makes the first move and he enters 3 and Alice enters 2, right? Now in this array, again Alice gives the move which is the minimum. 4 is removed. And then Bob makes a move and its the minimum is 5, it's removed. This array is empty. And here Bob comes up and he puts his number, which is 5, and Alice puts his number 4. So this is the final array we get, right? This is the question. And I think this question is quite easy because here we clearly understand that what we have to do. That Alice removes the minimum element, right? Bob takes the next minimum element, right? Let's see. Very a brief example. Let's say these are the minimum element, right? A, B, C, D, E, F in the order of ascending order, right? Now what will happen? First move, A and B are removed, right? Alice takes A and Bob takes B because minimum. And then Bob appends B and Alice appends A. Okay. The next move, C and D are removed. And here Bob appends first D, then C, then F, E. Just see what is this. If our answer is arranging the array in ascending order and interchanging the order of or swapping the first two elements, the swapping pair of two elements, right? So here, if we arrange this array 2, 3, 4, 5, so what is our answer? 3, 2, 5, 4. Here, 2, 5, 5, 2. So I think this is clear, quite clear. If I write the code in proof, there's nothing. And I think the time complexity is hardly n log n, and n is 100. It's too low, right? Simply you have to sort the array, right? Some sort begin, num sort end, and we have to swap every two element, correct? How? For int I equal to 0, I less than num sort size, I plus equal to 2, right? When we swap, correct? The first and the second element, then the third and fourth, similarly, and return this array. This is our answer. Simple. I think this should work. Yeah, this was quite clear. I believe this was not at all something tough here, right? An easy question. Now moving on to the second question. Okay, here the question reads maximum square area by removing fences from a field. Fine. There is a large m minus 1 into n minus 1 rectangular field with corners at 1 comma 1 and m comma n. Fine. Containing some horizontal and vertical fences given in array. Okay. Horizontal fences are from the coordinate. Okay. So they are given some coordinates basically, and they are saying these are the horizontal fences and similarly vertical fences. Okay. Return the maximum area of a square feet that can be formed by removing some fences, possibly none, or if it is impossible to make a square feet. Okay. Since the answer may be large, return it in multiple others. Okay, fine. So for example, this is how filled, right? M4 and 3, right? So this is how filled initially. Now the question says that's the horizontal fence in 2 and 1 3. 2 means this fence. Okay, let's see how other fences. The horizontal fence is I and 1. The horizontal fence is I to N. Okay. So from 2 1 to what is N? 2 3. Coordinate of 2 1 to 2 3. This is a horizontal fence, right? We draw here. This is 2, right? 2 comma 1. This is 2 comma 3. This is a horizontal fence as we can see. And one more is this one. 3 1 to 3 3. This one, right? We have two horizontal fences here. And vertical fence, we have two. That means how are we averaging it? See, vertical fences are 1 2 m. Okay. So here we can see it's nothing but 1 2 2 4 2. So basically like this here 1 2 2 4 2. This- These are all the fences we have, right? So we have to find the maximum square field area which we can get, correct? So what did they do, right? They removed these three fences. They removed this fence and this fence. Now we are getting this part, right? And yeah, so this is a square field with areas. This length is 2, that is 2, that's 4. That's it. So we remove these two fences to get this area. So the question says basically we have to remove some fences. We don't have to minimize how much we have to remove, right? We have to remove some fences, return the maximum area of a square feet that can be formed by removing some fences, possibly none, or -1 if it is impossible to make a square feet. So our task is to maximize the area of square feet, not to minimize the removals, right? Okay. One more here if you see, right? If we draw, let's try to draw the fences here. So horizontal fences is 2. That means from 2 1 to 2 7. This one. And vertical is 4. That means from 1 4 to 6 7. 6 4. So we have two fences here, right? And we want to create a square field by removing some fences, right? It can be proved that there's no way to create a square field by removing fences. Why is that so? Yeah, obviously we cannot form because if we remove this fence, right? Let's say, then this is not a square, right? Because this is one. This is how much? 4. This and this 3. This also 3. Now if we remove this fence, right? This vertical fence. So this is 1 and this is totally 6. That's not a square, right? And this one also. This is 4, this is 6, not a square. And if we try to remove this fence, right? Which one? This fence. Then also this is not a square. This 3 and 5, not a square, right? So and if you remove both the fences, then also it's 6 and this is 5, not a square. So by removing any permutation and combination of fences, we are not getting a square. Yeah, I think the question is crystal clear. We have to remove some fences so that we get a square. And we have to maximize the area of that square. Correct? Okay, now let's have a look at the constraints if the question is clear. Okay, so I'm in a huge. But yeah, we cannot have more than 600 either fences. Maximum 600 fences of horizontal and 600 vertical, or a total of 1200 fences is possible. Okay, fine. Now we have to do this. Okay. Here the basic idea which comes up, right? Which you should think of. Okay, let's think of like this. Let's say a simple question, right? Let's forget the concept of fences. Okay. Let's say we have a rectangle. Okay. Let's say this is the length of 9. This is the length of 15. Okay. If I ask you what is the maximum area of square possible for this rectangle, if I want to make a square in this rectangle, what is the maximum area of that square possible? What will you say? Since this is 9, so we can cut a length or segment of 9 in the length part, right? Let's say we cut it here. This was 9. So you say maximum is 81. That's the max we can make out of this given rectangle. That's the max square area we can form out of this given rectangle, right? Okay, fine. If this makes sense, right? Now let's try to now let's try to answer this question when we have the concept of fences. Okay, how will we answer? Okay, I'm reading the chat. Try to answer. Okay, no, this way won't work, Chirag. Okay, see, let's try. So here, let's say in this case, we thought of that. Okay, the maximum fence which is possible is 9 into 9, 81, correct? So for forming that fence, for forming that square, what do we need? We want a dash with no horizontal fence because if we want the maximum possible, that's 9 into 9, right? And we have a length of 9, so we don't want any horizontal fence in middle, right? So if we remove all the horizontal fences, right? Now what we want? Okay, so this route is clear. Now we are having some vertical fences, correct? Now we want to remove vertical fences in a manner so that we can get a thickness of 9 again, right? Okay. How should we do that? Obviously, right? We should try because see, initially we have a fence at 1. This is a 16, right? Now we want a length of 9. So we should start from the beginning, right? Let's say 1 is at 1 is 16. Let's say we have a fence at 3, 8, 12. Okay. Now what do we need? We need a length of 9. So should we see if we keep a starting point as 1, can we get a length of 9? 1 to 3 is 2, no, 1 to 8 is 7, 1 to 12 is 7. No, it's exceeding 9. So from starting point 1, we cannot create a fence of length 9. Cannot create a boundary. So then from 3 to 8, it's 5, 3 to 12, it's 10. Okay, wait, we got it. We got it. So yeah, now answer is 81 possible. Let's say if there was no 12, then what would we have done? 3 to 8 is 5, 3 to 16 is 13, not possible. 8 to 16 is 8, again not possible. So okay, we can conclude there is no such partition possible so that we can get a length of 9 here. So dropping of the idea of 81. Now next, better fence, what we can do? For next good area, what can we consider? 8 into 8, right? 64. Now again, we have to do the same concept. We have to see whether a length of 8 is possible in any manner in this case, right? Can we, in this area, right? 1 to 3 is 2, 1 to 8 is 7. We have to check whether a length of 8 is possible here. And similarly, we have to check whether a length of 8 is possible in this manner, in this array, right? If 8 is possible, then we can check out 8. Are you getting my point? We can do this and this won't take much time, but can you tell the complexity if we do via this method? Okay, yeah. Huh. So Akansh is saying this is the complexity. It's fine, but the thing is, if you see this question, right? Okay, although we have the fences as 600 only, but the main concern is we have a total of like, see, here we took the cases, the maximum area possible is 9981 or 64. So we can have maximum of 9 cases in this case. But if you see the constraint, right? Here we have m and n as 10 to the power 9. So we have 10 to the power 9 possible digits. That's not possible to iterate on each possible area of square. So what should we do? If it's not possible to iterate on each possible area of square, what should we do? See, a simple thing which we can do here, right? It's very easy. We can make all possible. See, let's say we have the horizontal, right? Area one, we have a fence, like one, we have a normal fence, right? And let's say we have one at A1, A2, A3, A4, A5, and M. Okay, these are the fences we have, correct? Okay, fine. Now, what are the total different lengths possible? What are the total different lengths possible? One is A1 minus 1, correct? A2 minus 1. Similarly, up to M minus 1 are the total different lengths possible horizontally. Similarly, A2 minus A1, A3 minus A1, A4 minus A1. You are getting at my point. These are different lengths which are possible in future. Correct. How many are total will be there? Total of M square, right? And M is 600, so it's not more. M is 600, it's not more. Why? 600 into 600 is 3.6 into 10 to power 5. These are total different possibility horizontally. Similarly, we can find a total different possibility of lengths vertically. Then we can match the maximum common they have. Let's say the horizontal lengths are possible are 1, sorry, 10, 28, 36, let's say 52. And in the vertically we have 100, 92, 86, 28, and 4. Yeah, 28 is the highest common. So this part we can cut out as length, and this part we can cut out as breadth, and we can get a common square of 28 cross 28. You understood my point? So this was the essence of this question. If you got my point, we have to take out all possible lengths and breadths that are possible, and we have to choose that length and breadth which is the highest common in both the array. And if we don't have anything common, then okay, it's fine, -1 because there's no possibility. If we check for any example, right? If we check for any example here, so if we check here, right? Horizontal fences. So these are the horizontal fences we have. So at which point do we have one, two, three, four? What are different and possible here? One, two, three. Again from here one, two. Here again one. So we have one, two, three. There are three different and possible. So vertically we have one, two, three. Again we have that possible is one, two, one. So one and two. What's the highest common among both the array? Two. So our square area is two into two, four. You understood my point, right? Yeah. So this you can simply code it, right? You can just make two arrays and you can find the highest common in both the array and multiply that modulo. This is the answer. Because you have to do modulo because the highest number can 10 to the power 9 in both the arrays. So the question says do a modulo. Make sense? I'm waiting for your answer in the comment section. Yeah. So yeah, I think it makes sense. Many of you have given a positive answer. Yeah. Okay, fine. If anyone has any doubt, then feel free to ask. Okay. Moving on to the third question. Okay, fine. So yeah, the third question says you are given two zero index string source and target, both of length n, find, consisting of lowercase English letter. You are also given two zero index character array, original and changed, and an integer array cost, which represent the cost of changing the character original value to the changed type. Okay. You start with the string source. In one operation, you can pick a character X from the string and change it to the character Y at the cost of Z. If there exists an index J such that cost J equal to Z, original J equal to X and change J equal to Y. Okay. You start with the index. Okay, let's see an example. It will be more clear. Return the minimum cost to convert the string source to the string target using any number of operations. Okay, fine. So basically, right, the question says we have a string source ABCD. Now we want to find a string ACBE, correct? Okay. Now these are the changing criteria, right? That means if we understand what I understood from here is okay, fine. Like if we change A, right, to B, our cost is 2 rupees. If we change B to C, our cost is 5 rupees. Changing C to B again is 5 rupees. Changing C to E is 1 rupee. Changing E to B is 2 rupee. And D to E is 20 rupees. There are different costs associated. Okay. Now we want to convert from here to here, right? So what is the minimum possible cost? Okay. So A to A. Okay. Now from we want to convert from B to C. Is it possible? Yeah. Like either we can go directly from B to C or we can go some like let's say from B to C the cost is 5. Okay. Let's calculate this. Then converting from C to B the cost is again 5 plus D to E. What's the cost? 20. Total cost involved is 30. What's the answer for this one? 28. Okay. So yeah, here comes the trick, right? How is it 28? Let's see. Okay, the conversion we did from C to B, right? How did we convert this C to B? This is the catch here. How did we convert this C to B? This C to B, how did we convert? First, we saw direct conversion. C to B is 5 rupees. But we can do in this one, right? From C to E, we can convert in 1 rupee. From E to B, we can convert in 2 rupee. C to E to B. We reached our goal via E. This is 1 plus 2, 3 rupees. Sometimes we go from two different city via different PN just to save our money. Although it takes a lot of time, and this is what this question is gonna do, right? So I think our task is clear, right? We have to convert from one character to another character, and we want to do that in minimum possible cost. That's it. For that, we have a graph. Basically, this is nothing but a graph. If you look properly, this is nothing but a graph. What graph we have? Like A to B, let's say B to C, C to B, directed graph basically. C to E, E to B, and D to E. From D to E. Okay. And we can have weights assigned, right? A to B weight is 2, B to C weight is 5, C to B weight is 5, C to E the weight is 1, E to B the weight is 2, D to E the weight is 20. Okay. We have weight assigned to this graph. Okay. Now, now it's like we want to convert B to C. So which one we should use, right? Or we want to find a shortest path from B to C. This is our question. Now we start. Our source is B, our destination is B. Find the shortest path is 5. We want to convert from C to B. Source is C, destination is B. Now we try by all possible paths. One path is this one, cost 5. One path is this one, this cost 3. We try all possible path and we get our desired answer. So I think the question statement is quite clear. So basically we have a graph and we are given multiple sources to destination, and for each source and destination we have to find a shortest possible path. If the path is not possible, then we stop. Fine. This makes sense. Let's see the complexity involved here. Okay, so yeah, that 10 to the power 5 shows the target length. So it appears that if we do, but it's not a problem, right? Why? See, how many can they give us? Like in, okay, in the source we have 10 to the power 5 characters, let's say. The target we have this many characters, so you're asking for each character we have to convert, right? But how many different combinations are possible? But they can give us from A to B. Like this, they can give us 25 possible choices. Similarly from B to, so we have 25 possible choices for each character. So maximum of 26 into 25. That's nothing but 650. Different conversions are possible. Like they cannot give us what can they give us except this. They can ask us to convert a character from A to B, or from A to C, or from A to D. Similarly, from A to Z. Similarly, from B to A, B to C, B to, so 25 for each character. 25, 650. Maximum 650 different combinations are possible. Although the string length is 10 to the power 5, but they cannot have more than these combinations. So we have to do this thing, okay? What do we have to do? We have to do a simple DFS or BFS, whatever, 650 times. Simple. Like what's DFS, BFS? Like we have a graph and we want to convert from A to C. So we fix our sources C, destination is A, sources A, destination is C, and we find all possible routes from A to C and the different cost associated with those routes. Correct? And the minimum cost we taken. Simple. I think this makes sense, right? If you see it here. So, what now you can say, sir, 650 times you have to do this at max, and the graph length is 10 to the power 5, so 650 to 10 to the power 5 cases. No, that's again not possible because the question says itself that this length, right, can be maximum of 2000. So, maximum number of edges in the graph is 2000, right? So, 650 different times we do, and at most we iterate on each edge once, right? So, 650 to 2000 is again, it's within our limits, I believe. And how do we iterate? Let's see a basic graph, right? Let's say this is a source, right? Okay, we have made different possible cases here, right? So this is our source, and this is our destination, this is our helper, right? So what shall we do? We run it, let's say we are doing by DFS, right? We go here, then from here, we again go here, from here, we go here, and we reach our destination. So in the answer, we can update our distance meter. Let's say answer is max. The answer is nothing but now this one, right? Minimum of maximum of this. Now we revert back, revert back, revert back. From here, we go here. From here again, we go here. We again update the answer value, right? Similarly, we revert back. We go here. Here we go here, and we again update the answer value. And from here, we again go here. We go. Now we cannot go here, right? From here because the edge is not straight, so we return back. So yeah, out of all the updated answer value, we can store our answer. So basically, we have to make a directed graph and do this. And probably, if I don't think we can anytime run into complexity issues like in the graph, one may say that we are iterating it so many times. Like from here, this path we came here, then we went here. From this path also we came here and we went here. This path also we came here and went here. So we are coming on the same node so many times. So like to avoid this, what we can do is we can store answer at each node, right? That minimum distance from that node to the destination. Like when the initial, right? We came here, we went here, then here, then here. Okay, we called. So we got our answer. Like we we went to the destination, right? So we can we can set some bool variable, right? Flag to true, then return. So this was true. So what was the cost from here till here? There was some cost, right? For coming here, there was some cost associated. So from here, when we went, there was some cost associated, right? What was the cost? We know this length of the SS, we can update. Okay, this is the cost. And we can send back what? We can send back the cost from here, right? Whatever we encountered, the cost from this edge. We can send it back. Now here we have what? Here we can say, okay, from here we got some flag variable is true. That means there was some possibility from the path we chose from here. And what was the cost? We got some cost in this answer, right? Return some X. We got some cost here. And this length, right? He knows his length. So this length plus that is the total cost via this path. So he can update his answer. Similarly, we can go via this way. And from each way, we can get some cost associated and we can get the answer updated, I believe.